So far, we have gone through creating fields and methods for class objects. These fields and methods are called instance fields and instance methods. When you create an object from a class, each object has their own copy of their fields, which is called instance field, because the object created is an instance. So its copy of fields are instance fields. Instance methods are methods that are not declared with a special keyword static. So instance fields and instance methods require an object to be created in order to be used. For example, in the room area Java in textbook, it defines 3 rooms. Each is a rectangle. We have to use the new keyword 3 times, each time creating 1 rectangle and assign the rectangle's address to the rectangle variable. So it will end up like this. There are 3 variables, kitchen, bedroom, den. Each contains the address of a separate rectangle instance. And inside this instance, inside each of the instances, there's a length and a width field. And this length and width fields belongs to that specific rectangle. Each instance of a class has its own copy of instance variables. The rectangle class defines the length and the width. Then each instance can have different values stored in the length and the width field. Instance method requires an instance of a class be created. Otherwise, it has no, because typically it will interact with instance fields or calculate values based on those fields, right? So without instance field, there's nothing for instance method to operate on. And variables defined as instance fields in a class can be accessed by any instance method in the same class as a field. If an instance field is declared with the public access specifier, it can also be accessed by code outside the class as long as an instance of the class exists. However, as we discussed before, this is not recommended. And the method can have a parameter variable, which is a local variable of that method. Within the method, variable name must be unique. A method must have a local variable with the same name, may have a local variable with the same name as an instance field, which is called shadowing. Local variable will hide the value of the instance field. What does that mean? That means local variable has a higher precedence over the instance field. So when Java virtual machine try to look for the variable by name, it always finds the local variable name first. It won't go to the instance field of the same name because local variable have a higher precedence. So this is effectively hiding the value of the instance field. Because of this, shadowing is discouraged and local variable names should not be the same as instance field names. When you define your parameter, you need to pay attention to this. Versus instance field and instance method, there's also something called static field and static method. There are information, there are properties and actions that do not belong to a single instance of a class. Rather, it belongs to the whole class. For example, in a mathematical calculation, the square root, the way you calculate square root is the same across different numbers. Whether you calculate square root for 25 or 100, you use the same method. Because of this, the square root method is actually static, it's outside of any specific instance of numbers. To invoke a static method or use a static field, you use the class name rather than the instance name. Because, for example, here, you use the math class name dot square root method instead of creating a new math object and use that object to call square root. Class fields are declared using the static keyword between the access specifier and the field type. Access specifier being private or public, and field type is data type. The field will be initialized to 0. only once when the class is loaded by JVM, by Java Virtual Machine. No matter how many operations you operate later on, this field will not be initialized again, but it can be changed. Primitive static fields are initialized to 0 if no initialization is performed. However, we always recommend you to explicitly define this as 0 instead of letting Java do the initialization. So let's take a look at the countable method, countable class. This countable class has a static int of instance count, which is initialized as 0 whenever Java Virtual Machine loads the countable first, the first time. Then, when you call a new statement to create a countable instance, a countable constructor is called. But this time, the instance count is not initialized. Rather, Java Virtual Machine will execute this instance count plus plus to add 1 to instance count. So remember, there's only one time that this is initialized, which is the time when countable class is defined. Then when each instance is created, you will add 1 to this instance count. And here, it will start with 0. Each time you create the object instance, you will add 1 to this field. And when you have 3 objects, or will have 3. Methods can also be declared static by placing the static keyword between the access modifier and the return type. When the class contains a static method, it's not necessary to create the instance of the class because you can directly use the class name to call the static method. Right. And static methods are convenient because they may be called at the class level. They are typically used to create utility classes, such as math class in the Java standard library. And they may not communicate instance fields, only static fields. And we will use an example to demonstrate this.